Hello friends. So this problem is about a disc sliding over the hill. So problem says we have a disc A of mass M and this disc is falling over a hill. So this is my hill. This hill and the curved portion of this hill is smooth. So friction coefficient is 0. So this is given in this problem that friction coefficient is 0 and height of this hill is h. So this is given and the lower end of the hill has a height of a small h. So this is moving, so this is falling, so this is applied very small push. So this block A or this disc A starts falling over this curved surface. At certain point of time this reaches here and once it reaches here it will gain some velocity and due to this velocity it follows a projectile path. So this is the projectile path and finally it hits the ground at a distance L from the foot of the hill. So we have to find this distance L so that this distance is maximum. So we have to maximize this distance. So let us read this problem. It says a small disc A slides down with initial 0 speed from top of a smooth hill of height h having a horizontal portion as shown in this figure. What must be the height of horizontal portion h to ensure that the maximum distance L covered by the disc? Also find L. So what you have to find? So you have to find L. What will be this L? So that is maximum. So you have to maximize L. So this is maximum L. And you have to also find what is the maximum, what is the height h. This is not the maximum. You have to simply find h. Now how will you solve the problem? So these are the things h and h. So this is given and you have been also given m if required. So using this you have to find. So you see this equation, this motion, there are two things. One is projectile. So you will need to write equation in projectile. So you have to write projectile motion equation. And the second hint you have that you can write energy conservation. So you can use energy conservation and to write some equations. So let us use these two equations and pause this video and solve the problem. Okay, so let us see the solution for this problem. So first we will apply energy conservation. So what is loss in energy? So once this mass or this disc reaches here, so there is loss in energy. So this distance is how much? This distance is h minus h. So capital H minus a small h. So this is the distance. So this is the loss in potential energy. So we will use this equation, that is loss in potential energy is equals to gain in kinetic energy. So how much is the loss in potential energy? Mass is m and g and height is h minus h. And what is gain in kinetic energy? So let's say this has a velocity v, so we can say half mv square. So from here I can write v is equals to, mass gets cancelled out, so v is equals to a square root 2z h minus h. Now we have to find this length. So I can write equation in x direction. Let's call this direction is x direction. So we can write equation in x direction, that is L is equals to initial velocity is v u plus at. This s is equals to ut plus half at square. So ut, so vt plus half and acceleration is 0 and t square. So this will be L is equals to vt. And what will be the time? We can find time by writing equation in bidirection. So this is bidirection in this case. So distance traveled is h is equals to ut. So there is no velocity in the h bidirection, plus half. Acceleration is in the downward direction and my downward direction is positive. So from here I can write t is equals to 2h by g and the square root of that. So we can write L is equals to Vt, and V is this under root 2z h minus h, and this is the time. Time is equals to under root 2h by g. So this simply becomes 2 square root h minus h times h. So we have to maximize this L. So either we can maximize L. So maximize L is same as maximize L square. Maximize L square. So why I am doing this? Because I will have less calculation. So L square will be 4 times h minus h into h. This is 4 times h into h minus h square. So if you differentiate this, that is dl square by dh, and put it equals to 0, so this will be, differentiation of this will be 4 times h minus 2h is equals to 0. So from here you can say h is equals to h by 2. So when height is half of the, so the foot height is half of the total height of the hill, then in that case you will have maximum range, maximum L. And what will be that value? So this value will be given by this. So L is equals to 2 times square root h minus h by 2 times h by 2. So simply plug the value of h. So this will be 2 times h by 2. So this is h. So maximum range in this case will be h. Now question for you. In this problem we said that this portion is horizontal. Now let us assume this is not horizontal. So this makes some angle with horizontal. Let's say theta angle. For example, you can have something like this. So you have here, so this is your hill, and then this is coming like this, but let's say this makes an angle theta. So everything is same, only thing is it makes angle theta. So from horizontal, let's say final position, let's make angle alpha or theta, and this alpha is given, or let's say alpha naught or theta naught. So this is given. Everything is same. This is h, and this length will be L. Once again, this will follow a parabolic path. This will be something like this. So in this case, how will you find the maximum L? What will be the maximum L in this case? So let us discuss all this in the comment box. And I hope you enjoyed this video. And if you enjoy, please like this video. And if you want, you can subscribe to my channel. Thank you.